Okay, section 6.2, the other trig functions, the graph. Okay, so if we're doing the tangent and we're going to do those important 5 points, 0, pi over 2 pi, 3 pi over 2, 2 pi. Okay, and we have our coordinates there from our circle. The tangent is the y over x. So we can see that the tangent just bounces back and forth from being equal to 0 and undefined. Okay, so we can also see that the period is pi, which means it goes 0, undefined 0 at pi. So the period is pi, where it repeats, it starts over that cycle. Okay, and this is the graph of the tangent. Now, what does the domain mean? The domain means what angles can we have, like x in our graph. Okay, the tangent is undefined at every repetition at pi over 2. So every pi over 2, we can see that it repeats. Okay, and there's these imaginary asymptotes where those borders are like an imaginary line where the graph can't touch. It gets closer and closer to it. Okay, so you can see it pi over 2, and every repetition of another pi. Okay, so what does pi over 2 plus pi k mean? K is an integer. Integer just means our positive and negative numbers, whole numbers. Okay, so pi over 2 plus 1 pi. Pi over 2 plus another 2 pi plus 3 pi, or minus a pi. So that's pi over 2, 1.5 pi over 2, 2.5 pi over 2. From pi over 2 and then add a pi in every direction, that's where you'll have the asymptote. Okay, we see that the y's go on forever, so the range is negative infinity to infinity. Okay, now the secant. The secant is 1 over the x value, so same thing from 0 to 2 pi. We can see that this repeats in 2 pi. It takes 2 pi to come back to a full circle, or back to a one repetition. So we go from 1 to 1, from 0 to 2 pi. Okay, now we can see it's undefined at pi over 2, 3 pi over 2. Okay, so same thing there. If we have asymptotes at pi over 2, plus k pi means pi over 2 plus a pi left and right. Okay, now we can see that it can't equal 0. The lowest that it goes is -1, and the highest it goes is 1 in terms of this little separation at y equals 0. So the range is negative infinity to -1, those bottom upside down u's. And then our range for the u, the right side up u, is from 1 to infinity. Okay, the cosecant. The cosecant is 1 over the y value. So we have our 0 to 2 pi, our coordinates, 1 over the y value. And we can see that it's undefined at 0 and pi, 2 pi. So its period is, well, it's actually 2 pi because we go undefined 1, undefined -1, back to undefined. So that's its repetition, 2 pi. Okay, it's undefined at 0, pi, 2 pi. So we could just call that pi k. K an integer means it's undefined at pi, and pi minus pi, pi plus 1 pi, pi minus 2 pi. Those asymptotes where we have that dotted, okay, asymptotes where we have that dotted imaginary boundary. Okay, we got those imaginary boundaries. Okay, those are called vertical asymptotes. And the range is the same thing. We have negative infinity to negative 1 for those upside downs, and then 1 to infinity for the right side views. Okay, last one, cotangent. Same thing, 0 to 2 pi, the coordinates. Cotangent is the x divided by the y. So it bounces between undefined and 0. So it has a period of pi where it starts cycling over. Where is it undefined? At 0, pi, 2 pi. So we can't have the k pi, which means 0 pi, 1 pi, 2 pi, and so forth. Same thing, those vertical asymptotes where it can't touch. And the range, we see negative infinity to infinity. Okay, last thing, negative angles. Okay, think about the tangent of pi over 4 and the tangent of negative pi over 4. Okay, tangent is y divided by x for the coordinate. Okay, so the tangent of pi over 4 is 1. Negative pi over 4 is negative 1. So we can see the tangent of the negative angle is just the negative of the tangent. Okay. Now the cotangent is x divided by y. Okay, let me just write that better. The cotangent of an angle okay, cotangent's x over y, so we also get that 1 and negative 1. Okay, just make sure when this is clear because I'll upload the notes. So it bounces back and forth between 1 and negative 1 also. So the cotangent of negative theta is the negative cotangent of theta. Okay, now if we notice secant, okay, notice the secant. The secant of theta is 1 divided by the x. So in pi over 4 and negative pi over 4, the x value is the same. So the secant of the negative angle is the same as the secant of theta. Okay, the cosecant is 1 over y. Well, the cosecant at pi over 4 is square root of 2. The cosecant of negative pi over 4 is 1 divided by the negative. So the cosecant of negative theta is cosecant of theta. Okay, let's look in general. Okay, so think about pi over 6. This point, these points right there, any angle, let's call just this theta, and let's call this negative theta. Okay, so remember, just in general, theta goes up, negative theta goes down. So we can see that the x values are the same for the blue dot and the red dot. It's the y values. Theta will be the opposite sign for the y values. Okay, for this blue, it's up and then it's down. So only what has just x is the same for the negative angle. Okay, we can see the x's are the same, but anything that involves y will be the opposite. Okay, so the cosine of negative theta is the same as the cosine, but the sine is the opposite. Okay, and that is the end of our lesson, and I believe there's a few problems in my open math.